Hello, welcome back. Today in this tutorial we are going to see how we can create a Confluence MCP client using an Embabel framework. So the MCP client that we are going to create will interact with our Confluence MCP server that we created earlier. Now when it comes to our Confluence MCP server, these are the following operations that are supported. For example, we can list all the spaces that are available inside our Confluence. We can list all the documents that are available inside a specific space. We can create a new document using the specified title and the page content, or we can even view the page history or metadata for any specified page. Now when it comes to our Confluence MCP client, we can perform any of these operations all using a natural language. For this, we are going to build a simple REST API with which the end user can interact, and they can also specify the command for the operation that they want to perform. For example, user can send the command to create a new page inside the specified space with the required title and the content. Now this request will be processed by our MCP client. MCP client behind the scenes will interact with the MCP server, and MCP server will actually create a new page inside the specified space and give the response back to the MCP client, and then MCP client will send the response back to the end user. So this is how the response will look like, containing the detail of the operation that was performed and the overall status of the request, like the successful message or what kind of operation was performed and so on. Now before we jump into our coding part, let's quickly understand the overall project structure. So our application is going to be the Spring Boot based application, and the name of our application will be Embabel Confluence MCP client. At the very top we will have the Spring Boot main class. Then we will have the controller package, inside which we have one controller class. Now inside this class we are going to create the REST API that will accept the request from the user, and once the request has been processed, it will send the response back to the user. Then we have the agents package, within which we will have our Embabel agent. Now this agent will understand the request that is sent by the user. It will intercept what kind of operation user wants to perform related to the Confluence, and then it will invoke a particular Confluence tool for performing the required operation. Then we have the config package. Inside the config package we have the two classes. First one is related to configuring the open router models. So inside this class we are going to configure the free models that are offered by the open router platform. Then we have the Confluence tool config class. Inside this class we are going to create the tools group, which will contain the set of tools that can be utilized by our Embabel agent. Then we have the DTO package. Inside this DTO package we have the request and response classes. Then we have the application.yml containing the basic configuration related to our application. Then we have the pom.xml containing project related configuration. Now let's go through our code base, starting with the pom.xml. At the very top you will notice we are making use of Spring Boot version 3.5.8, and when it comes to Java version we are making use of version 21, and for Embabel we are making use of 0.3.2 snapshot version, which is the latest version available at the time of recording this video. And if you are looking for a stable version, you can use 0.3.1. Coming to the dependencies section, first we have added the Spring Boot starter web dependency, which will help us to create the REST APIs. Then we have added the Spring Boot starter actuator dependency. This will be required while configuring the free models from open router platform. Then we have added the Embabel agent starter, which will help us to create the Embabel agents. Then we have added the Embabel agent starter OpenAI. Now since we are working with the free models from open router platform, we have added these dependencies. The models that are offered by the open router platform are compatible with the OpenAI standards. That is why we have added this dependency. Then coming to the repositories section, here we have added two repositories for downloading the artifacts related to Embabel. First one is related to the release version, and another one is related to the snapshot version. Now coming to the application YML, at the very top we have defined the name of our application. Then we have configured the port on which our MCP client will start. So we have configured the port as 8081. So before starting this application, we will have to start our MCP server, which will run on port 8080, and our MCP client, which is nothing but our current application, that will start on port 8081. Then we have configured the default model that will be used by our Embabel agent. In our case, we are making use of the free model offered by the Open Router platform, which is DeepSeek version 3.1. Now coming to this particular section, inside this we are going to configure our MCP client. Also, we will define how our MCP client will connect to the Confluence MCP server. So these are nothing but the out of the box properties that are offered by the Spring AI. So here you will see we have Spring AI MCP client, within which we are defining our MCP client with name Embabel Confluence MCP client. We have specified the version and we have defined the type as synchronized. Now when it comes to configuring our MCP server, we need to define how our MCP client can connect to the MCP server. For this, we have configured the SSE connections, which are nothing but the servers and events connection, within which we have defined one connection for our Confluence MCP server. And here we need to define the URL of our Confluence MCP server. In our case, it is localhost 8080/SSE. Now coming to our Spring Boot main class, the name of our class is Embabel Confluence MCP client application. This is nothing but the standard Spring Boot main class which will bootstrap our application. Now coming to the config package, inside this config package we have this class configure open router models. This is the Spring Boot configuration class which is extending the OpenAI compatible model factory. Now earlier I mentioned we are going to make use of the models that are offered by the Open Router platform, and these models are compatible with the OpenAI standard. That is why this particular class is extending the OpenAI compatible model factory. Now inside the constructor, we need to specify the configuration related to the Open Router platform. So here we have specified the base URL for Open Router. Then we have specified the path suffix for chat completion endpoint. Then we have specified the observation registry instance. This particular instance is provided by the Spring Boot actuator. That is why we added the actuator dependency inside the pom.xml. And now for interacting with the Open Router platform, we will need the API key. This particular API key will come from the environment variables. So this is the name of the environment variable, which is OpenAI API key. Inside this environment variable, we need to configure the Open Router API key. Now when it comes to configuring the models that are offered by the Open Router platform, for this we need to create the object of type LLM. Now I'm going to showcase you this for one of the LLM. In a similar way, you can configure it for the number of models that are offered by the Open Router platform. Since we are making use of the DeepSeek version 3.1, I will showcase you the example for this. Here we need to create an object of type OpenAI compatible LLM, inside which we need to specify the model ID. This is nothing but the model ID defined by the Open Router platform. Then we need to configure the pricing for this model, since this model is a free, due to which we have configured the pricing as 0.0 for both input as well as the output tokens. Then we need to configure the name of the provider. In our case, we have set it as Open Router. And then we need to define the knowledge cutoff date for our model. In our case, we have set it to January 2025. Now coming to our second configuration class, which is Confluence Tools Config. Inside this configuration class, we need to create a tool group containing the set of tools that can be utilized by our Embabel agent. But before we can create a tool group, we need the details about the MCP clients that are present inside our application. So when it comes to our application YML, we have created one MCP client with name Embabel Confluence MCP client. So the details about this will be mapped to this particular list, which is the MCP sync client. Now we have the list of MCP clients. We can create the tool group. For this, we have created one method, Confluence MCP tool group. Inside this method, we are creating the instance of type MCP tool group. Now inside this object, we need the details related to our MCP tools. For example, first we have given the description about our tool group, within which we have specified the description as Confluence operation including list spaces, create document and so on. Then we have defined the role of our tool group. In our case, we have given the name as Confluence MCP tool group. Now this is important, we'll come to this part. Then we have defined the provider for our tool group. In this case, we have just given the name as Confluence provider. Then we have given the name to our tool group. We have provided the permission. In our case, we have given the internet access to our tool group. Then we have mapped the MCP sync clients, and the details about this are already present here. Then we have the predicate within which we can configure what all tools should be available inside this particular tool group. Now when it comes to the MCP server, they can have n number of tools, but if we want to include only specific set of tools inside our tool group, then we can configure that inside this particular predicate. So in our case, what we have done is, so we are first getting the name of the tools from our Confluence MCP server. Then we are checking if the tool name contains the keyword like space, document and page. If yes, then only include that particular tool inside our tool group. So let's say if we have the 10 tools that are exposed by our Confluence MCP server, but we only need the 5 tools, then we can define the configuration inside this particular predicate. Now we have created a tool group. This tool group can be utilized by our Embabel agent, and for our agents we have created this package with name agents. Inside this we have this class Smart Confluence agent. Inside this class we are going to create our agent using the various annotations that are offered by the Embabel framework. So in order to define our agent, we are making use of @agent annotation, within which we have given the name to our agent, we have given the description, also we have specified the version for our agent. Now we have defined the agent. This agent can perform certain actions. Also it will try to achieve certain end goal. So in order to define the action, we have this annotation @action, within which we have given the description stating it can process the natural language request and execute the operations related to the Confluence. Then we have this attribute named as tools group. Inside this attribute, we need to give the value that we have defined inside the tools config class. So if we go to the tools config class, here we have defined the role name as Confluence MCP tool group. This same value we need to specify it inside the tools group attribute. And in order to define the end goal that this particular agent is trying to achieve, we have this @achieves goal annotation, within which we have given the description that it can understand the natural language commands and execute the specific operations. Now coming to our method, which is process Confluence operation. This particular method accepts 2 parameters as an input. First one is the Confluence request and another one is the operation context. Coming to the Confluence request, this is the Java record that we have created for accepting the request from the user. Now this operation context is provided by the Embabel framework, using which we can make use of the AI capabilities like interacting with the LLMs. If we go to our method, at the very top we have defined the prompt, but before we understand the prompt, let's see how we can interact with the LLM. So in order to interact with the LLM, we are making use of the context which is provided by the Embabel. Then we are calling the .ai method. Then we are specifying which LLM to use. In our case, we are making use of the default LLM which was defined inside the application.yml, which is nothing but the DeepSeek version 3.1. And then we are calling the .create object method, which will call the LLM and get the response. And in order to call our LLM, we are passing the instance of the prompt. This is nothing but the prompt that we have defined here. And in order to request the structured output, we have specified the name of the class here, and the name of the class is Confluence response. Now coming to the prompt, this is the prompt that we have defined here, within which we have defined the role for our agent. Then we are mapping the input that we have received from the user, and here we have defined the instructions stating if the request is related to Confluence, these are the tools that you can make use of, and simply process the request. Now coming to the structured output, for this we have defined this class Confluence response. If we go to this class, this is the Java record that we have created. At the very top we have the Confluence metadata, which is of type map of string of object. Now this particular map will be populated by our LLM based on the response that we have received from the Confluence MCP server. and when the Confluence MCP server returns the response, it may contain the set of fields and the object, due to which we have kept the type as map of string of object. Then we have the message field. This will also be populated by our LLM, and it will populate the user friendly message inside this particular field. Then we have this flag success, stating whether the request was successful or not. Also we have the operation type, stating what kind of operation was performed. So all these fields will be populated by our LLM based on the response that we have received from our MCP server. Now once we have the response, our agent will simply return it back. Now we have created our Embabel agent. This agent can be called from our controller. For that we have the controller package, inside which we have the controller class named as Confluence Operations Controller. Inside this class we have created the post type of endpoint, which will be called by our end users. So in order to define the path for our endpoint, we are making use of @request mapping annotation. The path for our endpoint will be API v1 Confluence. Since we are going to create the post type of endpoint, for that we have created this method execute Confluence operation, and we have annotated our method with @post mapping annotation. In order to accept the request from the end user, we have created this Java record named as Confluence request, containing the command field. This is something which we have already seen. The command which is sent by the end user will be mapped here. And once we have received the request, we need to invoke our agent. And in order to invoke our agent programmatically, we need to make use of agent invocation. First, we need to create the instance of agent invocation, and once we have the agent invocation instance, we can simply call our agent. So in order to create the instance of agent invocation, we are making use of the builder pattern, inside which we have specified the agent platform. Now when it comes to the agent platform, it has the details about all the agents that are present inside our application. Also, it is responsible for managing the lifecycle of all the agents that we have inside our application. Now in order to get the instance of agent platform, we are making use of the constructor injection. So here you will see the agent platform is getting injected. And once we have the agent platform, then we are configuring certain optional configuration using the process options. Now process option is useful to log certain additional information. For example, in our case, we are creating the instance of process option, within which we have defined the verbosity. When it comes to the verbosity, here we have defined certain configuration, like here we are stating that we need to view the responses that are sent by the LLM. We can also view the prompts using show prompts. Also, the planning that is done by our agent can be viewed using the show planning option. So once we have the verbosity instance, we will pass it inside the process option, and once we have the process option, we can specify inside the options method. And then we are calling the build method, within which we have specified the name of the class in which the response is expected. In our case, it is Confluence response class. This is the Java record that we have already seen. So once we have the instance of agent invocation, we can simply call our agent by calling the invoke method. So here you will see agent invocation dot invoke, within which we are passing the request that we have received from the end user. So once the request will go to our agent, it will process the request and send the response as per this format, which is the Confluence response. And once we have the response, we are simply returning it back to the end user. So this is how we can create the MCP client using Embabel framework. Now our Confluence MCP client is ready. We can simply test the same. But before we can start our application, we need to start the Confluence MCP server. And for that, we need to pass the three environment variables. First one is the Open Router API key. We need to pass it inside the OpenAI API key. Then we need to specify the base URL for our Confluence. Also, we need to specify the auth token for our Confluence. So once these three environment variables are configured, we can start the MCP server. And once the MCP server is started, we can start our MCP client by only passing the Open Router API key. Now I have started both our application. First one is the Confluence MCP server. So once the application is started, you will get the details about the number of tools that are exposed by our MCP server. And when it comes to the MCP client, here you will see the details related to the tools group. For example, it contains the tools related to the list spaces, list document, and so on. Now we will start testing our application. So in order to test our application, we need to send the request to this particular endpoint, which is API v1 Confluence, and the request type should be post. Inside the request body, we need to specify the command stating what kind of operation we want to perform. So the first request that we are sending is we are requesting our MCP client to list all the available spaces that are available inside my Confluence. So on the right hand side you will see the Confluence instance is open. So if I click on all these spaces, here the two spaces are present. First one is the Bunty Ragani and another one is the software development. So once we send the request to our MCP client, we should get these two spaces in the response. So now we have received the response, and inside the response body you will see the two spaces are listed. First one is the software development and another one is the Bunty Ragani. So these space details are present inside the Confluence metadata. Also it contains certain additional fields, and apart from Confluence metadata, the other fields are also populated, like the message field containing the user friendly message, the success flag stating whether the operation was successful or not, and also the operation type stating this was list spaces operation. Now we will test our second operation, wherein we will send the command to show all the pages that are present inside the software development space. So on the right hand side you will see the software development space is open, and these are all the pages that are present inside the software development space. Now when we will send the request, it should list down all the pages that are shown on the right hand side. Now we have received the response, but the request was failed. It is expecting the space ID as the input, which is of type numeric, and in our case it is passing the SD, which is the space key. We will retry our request and send the space ID as an input. So we have specified the space ID in the input. Let's retry this request. So yeah, now you will see the operation is successful when the space ID was specified. And if you see the response, it will list all the pages that are present on the right hand side. For example, first one is the template project plan, which is also present here. Then we will see if we have the hello final test. So let's look for hello final test. Yeah, so this is also present. So we have received the expected response. Now we will test our third operation, wherein we are requesting to create a new page with title 2026 project roadmap inside the software development space, and we have given some dummy content. So yeah, we have received the successful response in the first pass itself, even though we have not specified the numeric space ID in our input command, still it was successful. So in order to avoid such error, what we can do, we can add the improvements in case of our MCP server in order to avoid the confusion between the space ID, which is the numeric value, and the space key, which contains the letters. And if we refresh our Confluence on the right hand side, the new page should be present, which is 2026 roadmap. And here you will see the content that we specified in our input request is also present inside the page. Now we will test our fourth operation, wherein we will try to fetch the version history for this particular page, which is 2026 project roadmap. And I have also updated this page, wherein I have added this keyword dash updated, which will increase the version history for this particular page. So now when we will send the request with the command show me the version history for the 2026 project roadmap page, which is present inside the software development space, it should return the version history for this particular page. Yeah, so we received the response for the page history, wherein you will see the two versions are available for our page with title 2026 project roadmap, and the details about the versions are mentioned here. And also the user friendly message and the other fields are also populated. Now we will test our final operation wherein we will try to retrieve the metadata for this page 2026 project roadmap. So when we will send the request, we should get the expected response. So yeah, we have received the response for metadata as well, for which you will see the metadata fields are present inside the Confluence metadata object containing the details about the version, page title and so on. Also, the other fields are populated with the user-friendly message and the overall status. Now, while testing our application, you might have noticed that some of the requests were failing, stating the numeric space ID is expected, while some of the requests were successful in the first pass itself. This is because of the confusion between the numeric space ID versus the space key which contains the characters. So the requests that were getting passed in the first pass itself, behind the scenes, the request was failed once. Then our agent identified the numeric values expected and then it retried the same request. So for us, the request was successful in the first pass itself, but behind the scenes, agent has already retried the same. So I will showcase you this with one of the example wherein the user sent the request stating retrieve the metadata for this page 2026 project roadmap. Then our agent tried to process the same. So here you will see first it called the list spaces tool call, which will give the details about the spaces. Then it tried calling the list documents in spaces tool by passing the space key SD, which is wrong, because of which we receive the error message stating provided value SD, which stands for software development, is not the correct type. Expected type is long, which is nothing but the numeric value. Then agent identified that this is the error that we receive from our Confluence MCP server. Then it retried the same, but now it has passed the numeric space ID, which is 65772, and because of which our request was processed successfully. We received the response. So here you will see the request was processed successfully and our end user received the successful response in this case. Yeah, so that was all regarding how we can create the Confluence MCP client using Embabel Framework. For this, we have also written one detailed article which you can go through if you are interested. Also, if you are looking for the details related to Confluence MCP server, for that as well, we have the detailed article present. And the source code that we discussed during this tutorial for MCP client is also present on GitHub. You can check out the code and try the same. Yeah, so that was all from my end. I hope you found it useful. Thank you.